Now we're going to solve this complex equation. Note that z is a complex number. We want to solve the modulus of z plus z is 3 plus 4i. Remember that I squared is minus 1, and here z is a complex number. So here we can proceed in different manners. We can solve this one quickly by noting that we can write z in general as a plus ib. So a and b are real numbers, and we know that I squared is minus 1. Okay? And also we need to note that the modulus of z in terms of a and b is the square root of a squared plus b squared. Okay? So here we can set these conditions and write the equation, and we need to make sure that we use one key fact. So given two complex numbers, so we have z1 is equal to z2, with z1 and z2 are complex numbers. So these two numbers are equal if they have the same real part and the same imaginary part. Okay? So if we have z1 as a1 plus I b1 and z2 as a2 plus I b2, so these two are equal if we have a1 is a2 and b1 is b2. Okay, so this is a key fact that we're gonna use here when we solve. Okay, so this one is gonna be z2 and this one will be z1 in using this scenario here that we just said. Okay, so here, so we know the modulus is the square root of a squared plus b squared plus z, which is a plus ib, is equal to 3 plus 4i. Okay, so let's write this one in a nice manner here. So here, this is the real part, and this is the imaginary part of z1. Let's call this one z1, and this is z2, this one here. So these two are equal if we have these conditions here. So this will give us that b is 4. So the imaginary part here is equal to the imaginary part of z2. Let's say this is z2, this is z1. Okay, and after that we're gonna have the square root of a squared plus b squared plus a is equal to 3. Okay, now we have the imaginary part ready. So here, this is b, so we can plug it here and solve for a. Okay, so therefore we need to solve this equation here, this one, to get a. Okay, how do we do that? So b is given by 4, so we're gonna solve. So here we're gonna get the square root of a squared plus 16, because b is 4 plus a is equal to 3. So this is a radical equation that we need to solve. Okay, we know how to solve this kind of equations. So a squared plus 16 is 3 minus a. Okay, so here before we proceed, we need to impose another condition. Okay, so here this is always positive. To have this one positive, we need to have 3 minus a bigger than 0. Therefore, solving for a, we see that a is less than 3. That means a is in minus infinity 3. Okay, so we need to have a in this interval to find the solutions. We know that b is fixed, b is 4, but we need to find a. To find a, we can square both sides. Doing so, we're gonna have a squared plus 16 is 3 minus a squared, which is 9 minus 6a plus a squared. Okay, now we get rid of the a squared, and we have 16 minus 9 is minus 6a. So this condition here it's just minus 7 is minus 6a, and this will give us that a is 7 over 6. Okay, so we found a. So we found a and b, and therefore we found the solution. So the solution in this case is, so we know that a is 7 over 6, and b is 4, and therefore we know that z is a plus ib, which is 7 over 6 plus 4i. So this is the only solution for this equation. You can go back and check that this is right. Okay, so you can, there is one step that we're gonna skip, which is to verify that this complex number, this one satisfies this equation. Okay, so I think it's very easy to find it and to check it, and this is the only solution for this equation. You just plug the modulus plus z, and you see if this part is equal to 3 plus 4i, and it is equal to 3 plus 4i. If you want to do that, you can do it, but remember that the modulus, okay, the modulus as we have here, which is the norm or the length of this number, if we think of it as some segment, remember that the modulus is, so it's going to be 7 over 6 squared plus 4 squared, and you take the square root and you add z, which is this one, and you see that's equal to 3 plus 4i. You can do it in the calculator or just do it in your head, and you're going to see that's the solution. One key fact that we use here, so here we use this fact without proving it, but it's very easy and it's very straightforward to prove. Okay, so you can just see that if we have this a1 is equal to a2 and b1 is equal to b2 with a1, a2, b1, b2 real numbers, then we have z1 is equal to z2. Okay, and if we have z1 is equal to z2, we can get this result. So it's straightforward. You can prove it in your own way and write it down if you want to. So that's all we have for today. Thank you very much.